Hello and welcome to lesson 4. In this lesson you'll take your first steps in the world of Kubernetes. I'll start by showing you the dashboard, which allows you to deploy applications easily. Next I'll teach you how to work with kubectl, which is a core utility for working with Kubernetes. You'll learn how to enable kubectl tab completion as well as working with YAML files. And once we know how these work, we'll have a look at core Kubernetes objects as well as the API. This lesson, like most, also has a lab at the end to allow you to practice your skills. So at this point you have Minikube up and running. Time to start and run some applications. So how does that work? Well, one way to get it working is by using the Kubernetes dashboard. Kubernetes dashboard provides a web-based interface to manage resources in a Kubernetes cluster. It is not the interface that I recommend, but it's an easy way to get started and a friendly way to get familiar with what Kubernetes is doing. So I'd like to show you anyway. If you want to work with Kubernetes for real, you should really have a look at the command line interface, because the functionality that is provided by the command line interface is just so much more. Also, what is inconvenient is that cloud-based Kubernetes distributions often have their own web interface, which is based on Kubernetes dashboard, but which is different and where you will find different components, and that's confusing. If you use CLI, there's just a kubectl utility, and the kubectl utility is always the same. But nevertheless, the Kubernetes dashboard is a nice way to get familiar with what is happening in Kubernetes environments. Also nice is that in on-premise clusters, Kubernetes dashboard is not available by default, so you need to manually install it. But if you are using Minikube, Kubernetes dashboard is installed by default. Just type Minikube dashboard to start it. Let's go have a look. So I am going to type Minikube dashboard on the Minikube machine, the Ubuntu machine, and there you can see that it's enabling the dashboard. Now what does that mean? That means that in order to run the dashboard, some applications need to be fetched and some networking needs to be set up, and that is what we can see happening right here. It shouldn't take too long, but you'll be operational within a minute normally. Here also you can see some warnings and some error messages. In most cases while working with Minikube, I would say just ignore the warnings and error messages. In many cases they don't mean really anything. As you can see here, we have the dashboard, and in this dashboard, of course, it's telling us there's nothing to display. We need to run something. So how do we run something? By clicking the plus. If you click the plus, you get an interface in which you can run an application. And there are 3 different ways of doing so. We need to select create from form. And after creating from form, we can define the application name. So let's call it first Nginx. Now, talking about applications, in this course we are going to focus on Kubernetes, and in order to do so I keep the applications quite simple. So you will see a lot of Nginx, a little bit of MariaDB, and an occasional busybox, and that is basically it. We need to focus on Kubernetes functionality, and once you know how the Kubernetes functionality works, you'll be able to get your application up and running. Now, applications in Kubernetes are based on a container image, and Kubernetes by default is configured to consult the Docker Hub and the Google registry for container images. So just enter a name of an image that you expect to be working, like Nginx. Next, we need the number of pods. In Kubernetes, we want to do some scalability. And the scalability is obtained by running multiple pod instances. I'm going for 3 here. The service is about exposing your application to the outside. Now, I really need to tell you more about the service, so I'm keeping it to none for the moment. And I just want to run the deploy, and then we can see what's happening. So as you can see, the applications are currently in a state of pending. The state of pending, depending on the size of the container image that needs to be fetched, can take a little bit, anywhere between half a minute or even a few minutes. But in the end, the application will continue and you will see the state of running. So yay, we now have our first application running in Kubernetes. And I can imagine at this point you have lots of questions. How are we going to access it? How are we going to provide additional configuration? Well, that is what we are going to discover in the next couple of videos. For now, this is it. In the next video, I'll show you how to work with the kubectl command line utility. In this video, you'll learn about the utility of all utilities, kubectl. Kubectl is the main Kubernetes management utility, and you use it to manage any resource or resource property. It is likely that you are never going to use anything but kubectl to work in your Kubernetes environment. But there is also kubeadm. Kubeadm is a Kubernetes administration utility. You use it to build and manage clusters and cluster nodes. But that is something that is only happening if you use on-premise Kubernetes, which is Kubernetes in your own data center. Many people don't use on-premise Kubernetes, they just use it in a public cloud. So then kubeadm is not used at all. Now, how do we manage applications with kubectl? To do the equivalent of what we've just seen in the Minikube dashboard, you would use kubectl create deploy my app -- images nginx -- replicas is 3. So what we see here is kubectl create, which is creating something. Deploy is for deployment. The application in Kubernetes is a deployment. So if you want to run an application, you run a deployment. I'll give you more details about what the deployment is later, but for now just remember that the application is a deployment. Applications are based on an image, so you use -- image equals followed by the name of an image. If it's just a short image name, Kubernetes is trying to find it in the image registries that are pre-configured. And if you want to fetch an image from somewhere else, just include the full URL that allows you to fetch the image. Lastly, there's -- replicas is 3, which is taking care of the scalability. That will run three application instances, also known as pods, for you. In order to view the result, you can use kubectl get all, and that will show you if you were successful. Let's have a look. So here I'm back in the demo environment where I'm going to use kubectl get all to start with. And what do we see? We see actually the deployment that we've just created. So here is the deployment, which is the application, which has created a replica set. It's a component taking care of the replicas. And we have the pods that have been started. So if I use kubectl create deploy my app -- image is nginx -- replicas is 3, then what is going to be the result? Well, let's use kubectl get all to check it out, and you can see that the second application has been started. And in the application you can see some containers are still in a state of being created. That is normal because, as you can see, they're just 4 seconds old. It just needs a little bit of time before you can see the complete application running in kubectl get all. Let's talk a bit more about how to work with kubectl in the next lesson before we are going to talk about these different resources that are created. Now, one nice thing about kubectl is that it has very nice embedded help. kubectl -h is how it works. And you can use this -h option at any level. So at the highest level, kubectl -h gives an overview of the available commands. And then on specific commands, you can also use kubectl -h. Like kubectl get -h shows how to use the get command. And doing so will show examples as well as available command line parameters. Let's check it out. So if I type kubectl -h, this is what we see, all the different commands that you can use in kubectl. Doesn't fit on a screen, so pipe it through the Linux Lex utility to see the output page by page. So here we can see the different options, and in these different options, well, we have, for instance, kubectl create. Use kubectl create -h to see the help output. And on beforehand, you're better off piping it through less, because I can tell you most of the times the result doesn't fit on the screen. Now, what do we see? We see that kubectl create by itself has many available commands as well. So how does that work? Well, we include one more level, like kubectl create deploy -h. And really, this works for everything that you want to do with kubectl. So kubectl, any command, any subcommand, and in the beginning you see nice examples, and these examples are giving you ready to use code that you can try to find out how it is working. And below the examples you normally find the command line options telling you what else is possible. Kubectl -h is really like man pages in Linux embedded in kubectl. They are awesome, and they are going to help you a lot. And I would say, in case you have doubt about the exact syntax, use it. Amongst all the cool features that kubectl has to offer, there's autocompletion. So kubectl offers tab-based command line completion, like your ordinary shell completion. And it works for nearly all shells currently supported. So not just Linux, also macOS and Windows. You only need to make sure that underlying shell command line completion is available. So if you are on Linux, and on Linux you have a minimal installation without the bash completion package, you may find that kubectl completion is not working. Let me show you how to configure this. So in fact, configuring kube completion is simple. Kubectl completion, that's what I can give you. -h. Because, as you could expect, -h is giving you the help. As you can see, detailed instructions for all the operating systems. If I may give you an advice, if you are using kubectl on macOS or on Windows, read the detailed instructions. Or just give it a try using the examples that you can find right here. But as you can see, the examples are a bit limited, even if PowerShell nowadays is available. Now anyways, we are on Linux, and this is the Linux command that I need to use. So let me copy this command and let me show you before. I'm using kubectl tab, and I see files in the current directory. That's not what we want. So let me paste the source kubectl completion bash. And now let me use kubectl tab. And there we go. It's showing all these different commands. So how does that work? Well, kubectl create tab. And there we can see the different resources. Deployment tab. And it completes as far as you can get. In addition to that, when you come to the point where you don't know it anymore, continue by using kubectl -h. Really, it's the way to get yourself started with Kubernetes. So while working with Kubernetes, you may be working with YAML a lot. So in order to understand YAML, we need to understand a little bit about how Kubernetes resources are stored. That's happening in the etcd database. The etcd database is one of the core components of any Kubernetes environment, and resources are stored in this database in the JSON format. The JSON format is not easy to edit, and that is why YAML is the current format to define Kubernetes resources. YAML is very common. You find it in different solutions, and Kubernetes is just one of them. And working with YAML allows users to work the DevOps way with Kubernetes. DevOps way, that's all about configuration as code. So you are generating YAML files, you put them in GitHub repositories, and that makes it easy to do version control and to ensure that everybody uses the same code to create resources. YAML itself is relatively easy to learn. And the most important thing to know is that in YAML, relations between objects are defined by using indentation. So you have a parent object, and to specify the properties of the parent object, you use indentation to identify that it's a child. An important thing is that you should not use tabs but spaces for indentation. YAML doesn't like tabs, so don't do tabs. But I can tell you, you shouldn't be writing YAML too much. You should be generating YAML files. You can generate YAML files easily by using your kubectl whatever command, followed by two options. -- dry run is client. This -- dry run is client is performing a dry run from the client side. That means that it generates the code that would be sent to the Kubernetes cluster. -o YAML will print that code as YAML, and if you use Linux redirection to myapp.yaml, you send it to a YAML file. And that's how you generate a YAML file. And after generating the YAML file, you can use one of the following. You can use kubectl apply -f followed by the file name. That will apply the YAML code to the current running resources. And if the resource doesn't exist yet, it will be created for you. Then there is kubectl create -f. That will create a resource from the YAML file, but if it already exists, an error is generated. And that makes kubectl apply -f a little bit more flexible. kubectl replace -f will try to replace the current application code with the new YAML code that is provided. My advice, go for either apply or create. These are the most straightforward. Also convenient is kubectl delete -f. And that will delete the application exactly in the way that you have created it to the YAML file. That is particularly convenient if you have a YAML file that is creating a whole bunch of application components. There's another option to work with YAML, and that's kubectl get on whatever you want to see -o YAML. That will show you the current configuration in YAML. That's the entire configuration, including cluster status information, so that might be a little bit too much, but it can be cool for troubleshooting. Let's go check this out. Alright, let me start with this kubectl create deploy. My app -- image is nginx -- replicas is 3 -- dry run is client -o YAML. If I just run that, the YAML code is printed on my screen. Unfortunately, YAML code that is printed on the screen is not so very convenient, so you might want to use Linux command line redirection to write it to a file, myapp.yaml. So let's have a look at myapp.yaml. There we go. Here you can see that this command creates a deployment, and you can see all the different properties of the deployment. The spec part definitely is the most important part, because here you will see all the different properties that are around. Now the nice thing of this YAML configuration is that in the YAML code you can easily edit. But if you want to edit, you need to know what to edit. If you want to know which editing possibilities there are, there's a fantastic command, and that's kubectl explain. Use kubectl explain deploy if deployment is what you want to edit. .spec and pipe it through less. And what do you see? You see all the fields that you can use in the deployment specification. Like min ready sec. That's a minimum number of seconds for which a newly created container should be ready for it to be considered available. So by default that is set to 0. Is that a convenient option? Honestly, that's not the point I want to make. The point that I want to make is, let's consider that you think min ready seconds is a cool option. Now what are you going to do? You are going to the YAML code, and in the YAML code, taking care of the right indentation, you are adding min ready seconds, and you set it to whatever you want it to be. 5, for instance. Now the nice thing about this is that as soon as you know which options exist, and you can find out using kubectl explain, you can include all of these options at the right location in the YAML file. And that is what makes working with these YAML files so interesting. They go beyond the options that are available in standard kubectl command line functionality. And that is why this is incredibly important. Use it in combination with kubectl explain. We will do that a lot as we move forward in this course. Good, so now I have my app.yaml, so I can use kubectl create -f my app.yaml, and oh boy, I already have my app. Can you imagine? Well, kubectl delete deploy my app is what I'm going to do, and I'm going to run it again. kubectl create -f my app.yaml. Now my app.yaml is created, and we can figure out what's going on. Of course, we can use kubectl get all to get an overview of the application. And now I understand my app was what I originally used, and that's why it already existed. That's not really a big deal. What it is about is that we can see that the application is running. Now, if I want to figure out what exactly is happening, I can use kubectl get on the deploy my app and -o YAML and pipe it through less, and then I can see the entire configuration listed in YAML. Is that useful? Well, for troubleshooting it is. If you want to know exactly what is going on, this is where you go.
In the Kubernetes API, different objects, also referred to as resources, are defined to run containers in a cloud environment. So it's always about a container, the center of the universe in Kubernetes. But in order to run a container in a cloud environment, you need to add properties that allow you to manage how the different nodes in the cloud are going to run this container. And that is why we put the container in a box, and this box is referred to as a pod. Now this pod can be replicated. And if you are taking care of the replication, then this replication is managed by the resource called a replica set. A replica set really is an internal resource. You are not going to manage individual replica sets because all of this is included in a bigger entity, which is the deployment. The deployment is one of the standard ways to run applications. You will also hear about daemon sets and stateful sets. The idea is the same. It's about running multiple pods in your cloud environment. But that's not all. You probably want to have some storage as well. And that is why in Kubernetes you can work with persistent volumes. And the persistent volumes represent the storage that is available in a specific clustered environment. And in order to access the persistent volume, as you will learn later, there is the PVC, the persistent volume claim, which allows your container to access the storage directly. And still that is not all, because you want your application to be accessible, right? And that is why in Kubernetes exposing the application is happening through a service with the help of the ingress resource. Services and ingress together make sure that users are able to access the actual application that is running in the pod. And if you think that is all, still not. Because in your application you have configuration. And this configuration is stored in a config map. Config map really is a replacement of your good old configuration file. And config maps can be stored in a more or less secured way as well by using secrets. I'll tell you all about all of these resources in the next couple of lessons in this course. But keep this in mind. This is the big overview picture of all the resources that really matter in Kubernetes. It's not all of them, because the API is extensible. You can even add your own resources. But this is the core. This is what really matters.
In this video, I would like to tell you a little bit more about the API. So API stands for Application Programmer Interface, and it contains a blueprint of how to work with specific solutions. The Kubernetes API does not exist. Kubernetes has a collection of APIs. And this collection of APIs defines the resources that can be used in a Kubernetes environment. Kubernetes has different tools to work with the API. You might like kubectl API resources, which shows a list of resources that is defined in the API. Or kubectl API versions, which shows resource versions. And we already have briefly talked about kubectl explain, which allows users to explore attributes of Kubernetes resources as they are defined in the API and as they should be used. Let's have a look at this. So let me start with kubectl API resources, because that is listing all the resources that exist. So in the output of this command, you can see the name of the resource. Like here, for instance, pods. Also the short name, if a short name has been defined. And very important, the API version. If you are working with YAML files, you always need to address the API version to ensure that you are using the right API resource. There might be cases where one resource exists in different APIs, and that is why this API version is very important. API version v1 is a Kubernetes core API. That is how Kubernetes all started in the beginning. Apps v1, for instance, is the first major extension to Kubernetes. But as you can see, many APIs have been added because the Kubernetes API is extensible. We'll talk about namespace later. Here we have kind, and kind is the official notation of the resource. Now, Kubernetes APIs get updated, and sometimes you may have different versions of one API available at the same time. If that's the case, kubectl API versions is the best thing to do. Here, for instance, we see that this currently applies for the auto-scaling API, where we have no less than 4 different versions. It's very important that you know which versions are available and how to use these different versions. And we have already seen how you can get information about API resources using kubectl explain. We'll see much more of this in the next couple of videos. Alright, we are now at the end of this lesson. Let's do a lab. Use a Kubernetes dashboard to create an Nginx application, and based on the application that you've just created, export the configuration to the file mynginx.yaml. Good luck. So to start with, I need to use minikube dashboard, running that as a background command. And from there, we can see the current configuration with already 2 different deployments. I'm going to add a new application using create from form. And let's call it lab4, container name, Nginx. And everything else, I can keep that to the standard. So I'm clicking deploy. And then we can see that the application is being added. You can also see the list view of the resources that have been created right here in deployments and pods for all the related resources and so on. Now let's leave the dashboard alone and let me use kubectl get deploy, which is showing me I have the lab4 deployment. So kubectl get deploy lab4 -o YAML, that is producing the YAML code for this deployment. Now the goal here is that we export that to lab4.yaml, and then we need to clean up this lab4.yaml. The thing is that this is the running state of the application. And in the running state of the application, you can find lots of information that is generated by the cluster. So what can we remove? Well, we can remove from metadata the annotations, the create timestamp, and the generation. So that's 4 lines. Then we can remove the resource version and the UID. So that's another 2 lines. We can keep everything that's in the spec. That's a specification, and most of it is good. And then we need to remove everything that is below status. That's the current status information in the cluster. So here we go. Now we have a backup of the running application. So I can change what we've got here, and I can use kubectl apply or replace to replace the current version of the application with this code. That's what this lab was all about.